Hello, thank you for attending the Kingspan Off-Mains Wastewater Solution, CPD. The agenda is as follows: understanding wastewater treatment, sizing a sewage treatment system, sewage treatment systems, site considerations, typical installation, followed by questions at the end. Understanding wastewater treatment, the process, definition of terms, sewage characteristics. First of all, the process. Although a sewage treatment plant mainly is in a single casing, the treatment process is split into a minimum of 3 different parts. First of all, we have primary settlement, followed by biological treatment, followed by final settlement. Also, tertiary treatment may be required if the effluent quality is needed to be more strict. The definition of terms. Population, or P or PE, is basically the number of people the system will serve. PE stands for population equivalent, which brings everything back to a domestic equivalent population. BOD, or biochemical oxygen demand, is basically the amount of oxygen required to treat the sewage, i.e. if raw sewage is thrown into a river, it needs a certain amount of oxygen to break the sewage down. Hence, if we reduce the BOD in a treatment plant, less oxygen will be required out of the water, which is more beneficial to fish and plant life. The ammonia, or ammoniacal nitrogen, in wastewater we frequently refer to and use as ammonia. The term ammonia usually includes ammonium as well. Suspended solids are the small particles which remain in suspension in the water. Sewage characteristics. As you can see on the screen, this is split into raw sewage, settled sewage, septic tank sewage, BIODISC treated effluent, and nitrifying BIODISC and ENVIROSAFE HEQ. The BOD figures in raw sewage are 300 to 400 milligrams per litre. The BOD in settled sewage, i.e. primary settlement tank, is about 200 to 260 milligrams per litre. In a septic tank, this can reduce down to 150 milligrams per litre. However, in some septic tanks, the BOD may increase due to the sewage going septic. In a treatment plant, we try to get the BOD levels down to 20 milligrams per litre. In suspended solids, again in raw sewage, the quantity is 300 to 400 milligrams per litre. In a treatment plant, we can get this down to 30 milligrams per litre. The ammoniacal nitrogen in raw sewage is 40 to 60 milligrams per litre. In a septic tank, this may drop to 20 to 40 milligrams per litre. In a sewage treatment plant, we can reduce this down to 20 milligrams per litre. In a nitrifying sewage treatment plant, we can reduce this further down to 5 milligrams per litre. Sizing a sewage treatment. Sewage is split into 2 parties, domestic waste and commercial waste. Dealing with domestic waste first, this is basically the flow as you would have in a normal household. The flows range from 150 litres per person per day, using an organic load of 60 grams of BOD and an ammonia load of 8 grams. Waste produced from toilets, baths, showers and kitchen waste, washing machine and dishwashers. The domestic waste strength is BOD concentration is approximately 400 milligrams per litre. For the last 30 years or so, the domestic flow was set between 180 and 200 litres per head per day, which is calculated to a concentration of between 300 and 333 milligrams per litre. Due to the fact that water-saving devices have been used, the flow is now reduced to 150 litres. Looking at a couple of commercial waste applications, first of all we have a school where the flow is much less than normal domestic housing, down to 90 litres per person per day. However, the BOD in proportion increases to 38 grams. In a typical commercial situation, you would normally find flows are lower generally than domestic. However, the organic load, i.e. BOD and ammonia, is much higher in proportion. Looking at a small school scenario, you would have pupils using 90 litres per day, full-time staff at 90 litres per day and part-time staff at 45 litres per day. The BOD levels would be 38, 38 and 25 grams per head per day respectively, with the ammonia at 5, 5 and 3 grams per head per day respectively. Looking at a typical commercial industrial waste scenario, we would have the flows for an office stroke factory without canteen at 50 litres. However, with a canteen, these may increase up to 100 litres per person per day. Full-time staff, the flows would range between 50 and 90 litres per day, with part-time staff on approximately 45 litres per day. Again, the BOD levels would increase and reduce in combination with the type of application. Again, commercial waste on some industrial scenarios. We're again looking at an office stroke factory. Workers will be 100 litres a day, with the casual workers on 45 litres per person per day. BOD levels again set at 38 or 25 grams per head per day respectively. In a commercial waste hotel type scenario, a lot more factors have to be considered. We'd be looking at hotel guests. What type of hotel is it? Is it a prestige hotel or is it a 3 to 4 star hotel? Are the guests just bedroom only with no meals? Is it a large hotel with residential conference guests or perhaps non-residential conference guests? Is there a bar area? Is there a restaurant area? I.e. we'd need to calculate numbers per drinkers per day. What is the type of restaurant there? Full meals with luxury catering, pre-prepared catering, or just snack bars perhaps in a bar area? We'd also look to take into consideration if there's any function rooms, including buffets if there's weddings there, perhaps done on a weekend. Again, if you're looking at commercial applications, on amenity sites, there may be things like toilet blocks. Is it a golf club? Is it a local sports club? Again, we'll be looking to break down all the numbers for people in this type of application. Tent and caravan sites, again, we'll be looking to break down for the numbers so we can calculate the loads accurately. Caravan parks and campsites. These can be a little bit more tricky because obviously in the summer use we'd have very high loadings, and perhaps in the winter the site may be down to a bare minimum or even closed. Hospitals, residential care homes. These need to be assessed almost individually, as the flows can range between 350 to 450 litres per person, with the organic load double or maybe treble what you'd expect in a typical domestic situation. Site assessment and options. The first thing to look at would be, can we achieve connection to mains drainage? The first thing the Environment Agency would ask is, can we achieve this? So if we cannot achieve this by gravity, the first thing we'd look at is a pumping station. Now the selection of the correct pumping station is critical. Part H3 of the building regulations requires that the pumping stations should now have 24 hours storage in the chamber in case of breakdown or power failure. What else do we need to know? The volume of the waste. Is it a single house application? Is it multiple housing applications? Is it commercial? We can work out the flows as we have just done on the previous pages. The type of waste. Is it raw sewage? Is it treated effluent from a septic tank or sewage treatment plant? Or is it surface water? We'd also need to know the distance to be pumped horizontally, plus the total height to be pumped. The inlet depth into the pump station is also critical, as this will determine the depth of the well. The diameter of the rising main can be calculated, depending on the flow required or the flow available. Power supply is also critical. In large head applications or commercial applications, 415 volt 3-phase power is almost essential. The final question would be, would we require solids handling or a grinder pump or an effluent pump? Installation of a septic tank or treatment plant. The picture shows two options. The first one is a septic tank application where it's clearly visible that the drainage field is much larger than the treatment plant option below. This is because septic tank waste is inherently thicker and sticky. Also, the ground is used as a filter in the septic tank application, whereas the ground is used as dispersal in the sewage treatment plant application. Right, the Environment Agency require all septic tanks and sewage treatment plants below 50 population to be certified to BSEN 12566. All Klargester tanks and sewage treatment plants comply to this certification. BSEN 12566. These tests are independent and carried out by approved test houses in Europe. Septic tanks are tested to BSEN 12566 for strength, water tightness, performance, solid retention to 99.5% efficiency. Wastewater treatment systems in BSEN 12566 are for strength, water tightness, performance over a 46-week period, BOD reduction, and suspended solids reduction. The most important part really for a septic tank system or sewage treatment plant system which is discharging into the ground is the subsurface irrigation system. The size of this can be calculated from the percolation tests laid out in BS 6297. Over the next couple of slides we'll show you the on-site percolation test method, interpreting the test results and designing a suitable percolation area. Essentially it's digging a hole, filling it with water and timing how long it takes to drain away. The on-site percolation test method. Basically you need to dig a hole down to your proposed invert level, 300 mm square by 250 mm deep. Fill this with water and time how long the water takes to drain away. This test is best done a minimum of 3 times to give a good accurate average. The area of the subsurface irrigation system can be calculated using the equation A equals P times VP times 0.25. The final 0.25 can be reduced to 0.2 in a sewage treatment plant application. P equals the number of people, PE, domestic equivalent, and VP equals the percolation value, i.e. the length of time in seconds the water takes to drain away 1 millimetre. From these results, we can calculate how much soak away is required from the septic tank or sewage treatment plant. Once we have our figure A, we can then divide by the trench width, which is typically 0.6 of a metre, to give ourselves a linear meterage of soak away requirements. Next, we move on to treatment plant selection. To design a sewage treatment plant, we need to take in lots of considerations. Is the application domestic or commercial? What is the effluent quality required? Do we need any further ammonia reduction? Do we need any further tertiary treatment such as phosphate reduction or total nitrogen reduction? Are there any planned future extensions? Is it a full-time or part-time usage? Are there very low flows, like there would be in perhaps a caravan site where it would do very little in the winter? Wastewater solutions. This slide shows the various offerings that Klargester can offer. There is the BIODISC system, the aerated system, which is a biosafe or bioefficient as far as Klargester are concerned, the septic tank system, or the larger BIODISC or larger ENVIROSAFE HEQ systems. Site installation. Installation considerations. Firstly, we need to ensure there is no surface or rainwater entering the system. Is there a requirement for pumps, or is a gravity system suitable? The inlet invert requirements on site. Some treatment plants, i.e. BIODISC, can be limited to 600 mm and 1100 mm only. Our ENVIROSAFE product is more flexible at 500 mm through to 2000 mm. Location is critical. Can the plant be easily desludged or maintained? Where is the discharge point? Is there a requirement for a grease trap? This slide shows a typical installation of a BIODISC. Note the invert at 600 mm, concrete slab and concrete backfill. If your invert on site is deeper than the standard BIODISC invert, then the ground around can be landscaped as this slide shows. This invert is typically deeper, whereas the unit is now recessed. If recessing is not acceptable on site, an ENVIROSAFE may be the answer. These can offer deeper inverts with the covers flush at ground level, as shown on this slide. This illustration shows a typical ENVIROSAFE installation. Note the covers will be flush with ground level. The large kiosk on the left-hand side is the blower housing. The small kiosk on the right-hand side is the control panel housing. Also, there is a separate above-ground venting system. Klargester can offer increased capacity systems such as modular systems, whether it be a balance tank followed by 2 BIODISC systems as this slide shows, or full modular systems using primary balance, treatment modules and final settlement tanks, usually done with the ENVIROSAFE HEQ system. What to avoid with a sewage treatment plant? Firstly, rainwater must not enter the system. This tends to cause turbulence in the primary settlement tanks and can wash bacteria off the discs or media areas. Chemical toilet waste must not be used. These generally do exactly the opposite to what you're trying to achieve in the plant, which is growing bacteria. Waste disposal units can be used, but we must be notified at the design stage, as these can add up to 30% of the organic load. Grease and cooking oils should not enter the system. If there is grease and cooking on site, we would suggest the use of a grease trap or grease separator. Chemicals such as weed killers, insecticides and fungicides should not enter the system. Medicines should not enter the system, as they will come out exactly the same at the other end. Rarely used these days, but photographic developing agents such as silver nitrates must not enter the system. Nappies and sanitary towels should be disposed of separately. Again, rags and soft toys should not enter the foul system. Home beer and wine making can be allowed into the treatment plant, but again we'd need to know the quantities used before designing the plant. Cleaning agents in their raw state, above and beyond what would normally be found in domestic situations, should not enter the plant. Kingspan Klargester can offer a full design, support and service, such as from sizing the full design and product integration, proposal review and approval, manufacturing and delivery, installation support, and full commissioning and maintenance program. Thank you for listening. If you have any questions, please contact me on chris.pike@kingspan.com. Many thanks.